Hello friends, and welcome to this second video on my power amp. So in this series of videos I'm talking about my power amp that I'm using to drive my Lundahl speakers, and it's an own design of mine. Rick G on the forums a couple of months ago actually asked me, can you tell me more about the power amp? So Rick G, if you're watching, this video is very much also for you. In this video, this is the second video in this series, I'll go into the schematic for this amp, and you see it in the underside of my amp for the first time. So this holy mess, experimental mess that you're seeing on the camera here, that's the flip side of the amp. So let's now start looking at the schematic. This is the thing that we'll be doing in this video, and I'll talk you through it with some of the things that are and details that are in there. So if you have a look, if you want to take a snapshot, now is your time. So, good. So if you look at this schematic, so we've got the input here, we've got the output there, we've got power supply connected here. We'll talk about that in video number 3. And so what we've got here is the output stages, the differential output stage. We've got an interstage transformer, we've got an output transformer, and here we've got the input tube or the driver tube. And here we got the volume control. So that's the general layout. Now let's get into the specifics. So as said in my introduction video, we're using a shunt 24-step volume control. And here is actually a grid stopper in here that's definitely needed for this. So there's a 1K grid stopper in here. And what you find here, as said in the introduction, these are directly heated tubes. And here we're using the 2P29L. So that's the, sorry, I used the pi symbol here. It's wired up as a triode. So it's directly heated by using a triode mode. And what I've done here is, and it's also done in the output stage, is on the screen I'm actually feeding it with a very high resistance, pretty high resistance that keeps the current low, and a Schottky diode. And I'm still sort of experiment. At some point I will remove them and then remove the Schottky diode and see if that makes a difference. Yeah. But the idea behind it is because the plate and the screen have different linearities. The curve via I versus V, so the current versus voltage, runs a bit differently. And what I'm doing by putting a high resistor in here is taking this out of the equation. So we're just running on the plate, with the idea being that this starts looking a little bit more like a real triode, and not having the mix of the screen thrown into the mix. And of course with some tubes you actually risk if you overloading the screen current, because that is just a grid here with very thin wires, while this is far more solid and can carry way more current than this can. So depending on the tube and the distances here and the density of that grid, it could be that you're overloading this, and so in this case there's no chance of that. The only thing is that you generally need a bit more voltage now, because the voltage here gets dropped quite a bit. It just means there's a bit more voltage here required here from the B+. Now the other detail here is, and this is one of the techniques that I've applied, is use filament bias. Because normally if you have a low current tube like this, so we're actually using about 127 volt and 9 milliamps here on the that runs through the tube, and is here in the node. When you have that current, you usually need quite a large resistor here to actually give you sufficient bias. However, if we're applying filament bias, oh sorry, let me do one step back. So once that happens, what you have is that the amplification with this resistor increasing is much lower, and so you would lose most of the amplification, because this is a low mu tube, so it only amplifies 9 times maximum. If this is completely ideal, this would decrease quite a lot, and therefore we apply a bypass capacitor. However, I find that bypass capacitors even though some people say that they're not in the signal part, they're very much in the signal part because they're immediately audible. The quality is always very important. So, but one way to overcome that is to use this resistor here also for the filament current. So now we're adding another 120 milliamps, and therefore this value goes down quite a lot. And if you then calculate what this tube does, it still has about ×8 amplification. So I'm using 44 ohm resistor, which is actually a 15 watt 47 ohm wire wound, and then paralleled with a 6 watt 120 ohm, I think, and that results in 44 ohms. So I'm using that. Gets a little bit warm, but 120 milliamps is not that much. And what I'm doing is there's 7.65. So really, if you would measure it at the middle, it's 1.1 volts lower, which is 6.55 volts bias, which gives enormous headroom if you consider that you'll have, you know, even with a 2 volt signal, which is actually a bit too much for this amp the way it's set up currently. But it's well within range. You have a huge headroom on the driver stage. And so yes, so here you got the phase splitting going on in the interstage. And let's just have a look at this. So this is also a common feature between the driver and the output stage, is that I've put a 20 Henry choke in here, a bypass by 25 UF, very low resistance, lower, so ESR, what is it? A very high current capable capacitor, and that is used to shield it from any negative effects that a tube regulated power supply might have. And this makes a real difference, especially in the driver stage. So the higher inductance that you can get here, the better it is. This has an immediate effect on the sound quality of the whole amp. All right, so we're halfway now, and let's just look at the output stage. So we've got this differential pair, we've got the phase splitting, so that's completely equal. We don't use a tube for that, we use an interstage transformer for that. Got nicely balanced, so positive and negative phase. Same triode setup, however, now I'm using a 20K. There's about 265 volts or so on here and 21 milliamps, mainly because, of course, the amount of current that runs through it is mainly determined by the screen voltage, which has been dropped a bit by that, so it needs quite a bit of current on here, or it has, just because this drops it quite a lot. And at the moment I've got 16 volt bias, which is a bit on the low side if you want to get maximum power out of these. And that is the reason, is because I've currently only got 21 milliamps running through each of these tubes, so 42 milliamps in total with 16 volts bias. Now, the bias, as said, is created by this rectifier tube, the 6C4P. Which is it's cheap to run in some ways. It's a small little 7-pin tube, and it does a big, beautiful job. So the nice thing about actually using a rectifier tube is one of the tubes would actually drop out. This bias voltage would not drop to 8 volt, but it actually drops to about 10 volt. So the reactive element in here I think has a very positive element compared to a resistor, and it only adds a little bit. This one takes like 450 milliamps at 6.3 volts to power this thing. So it's, you know, your power budget is not that much affected by it either. I think that's about all. So yes, if you want to get maximum power, like you really want to get the 4 or 5 watts or something out that you would get in probably class A1 still, you'll have to increase this bias a bit. So you have to choose either increase the current through this, so other very well-known operating points are 28 milliamps and 35 milliamps through this, and so that would have a higher thing, so like 24 volts or so, 20 volts or so. That would give you a lot more headroom before going into class A2, which is still not bad because this tube is extremely linear, so it's definitely possible to milk a lot of power. But if this is higher, it just means that you don't run into the A2 region of the tubes yet. So again here, same power setup, differentials here, the push-pull output transformer. and then of course the speakers here. So just to have a quick look at the iron that I used. So I'm using a Lundahl LL1660 in here, and it's wired up in the single-ended to push-pull, or to balanced. So it's 4.5 to 2+2, so there's a small voltage reduction in here, so about 20% that you lose there, but this gives the highest bandwidth. So this still has, I think, about 40 Henry while in this configuration. And then if we look here, I'm using the Lundahl LL2766, the push-pull model, and I've wired it up in 79 to 3. So this is one of the smallest transformers that Lundahl makes. Very much suited for small amps like this that don't have ridiculous quiescent currents. And because it's push-pull, of course, there's a huge capacity and huge inductance, so you get an enormous bandwidth and no roll-off to speak of in the bass region that I see with so many amp designs. Yeah, and generally speaking, if you want to improve on this amp, I would actually look at the quality of the iron and maybe mix and match a little bit with that. Currently, this is an unbelievably neutral, very nice sounding amps with a lot of subtlety, lots of transparency. Doesn't sound push-pull at all. Also doesn't sound really single-ended. Doesn't sound warm. But it has no mechanical element to the sound, so I think it's a very nice design. However, the big limitation that I spoke about before is its low gain. It's slow gain because the overall gain is probably maybe at best times 50 between these. So these are about probably times 8, and this one probably as well, maybe a bit lower. That reduces it somewhat. So. Maybe it's times 45 or so. And then of course it depends on how you configure this. You've got 4 options in wiring. There's 79 to 6, 79 to 4, 79 to 2 and 79 to 1. So lots of options here to actually match with your loudspeakers. Or to use as a headphone amp, as a brilliant headphone amp. I've put my headphone amp driving this to the Hi-Fi Main HC6, and it sounds really good with this amp. So that's the design. As you can see, no capacitors, very little components, mostly iron and directly heated tubes, which I think is a very good recipe for a good amp. Yeah, that's it. So this was video number 2. Video number 3 will be about the power supply. So we'll look at the regulation of the power supply, and we'll look at the filament supply here. And this one as well. You'll see that there will be some pre-made stuff that I'm using. Not that difficult. I hope you found this interesting so far, at least the amp builders amongst you, or the amp designers amongst you. Really, this schematic this has come via experimentation and taking some inspiration from, for example, Steve Bench, who had this setup, and I really like that. And yeah, some other amp makers that have contributed into what they've done. However, in the end, this is a bit of a unique combination of use and schematics. Probably I haven't really seen it, but parts will be seen with different makers. So yes, thank you for listening. Thank you for watching. I'll hope to catch you in part 3 or in one of my other videos. Rest me to wish you a very good day. And until then, take care and bye bye.